Dear students, now we are going to learn how to find the row space, column space and null space for the given matrix A. Let us consider the matrix A having two rows and two columns. Here this is R1, R2 and column 1, 2, 3. Before going into the problem, you should know the theorem. Let A be a m by n matrix, then the row space of A is the subspace of Rn spanned by the row vectors of A. Here the row vectors are R1 and R2. The column space of A is the subspace of Rn spanned by the column vectors of A. Here the column vectors are C1, C2 and C3. Third one, the set of all solutions of the homogeneous system of equations Ax equal to 0 is a subspace of Rn called the null space of A. That is n of A equal to set of all the solutions x belongs to Rn such that Ax equal to 0. And here the dimension of row space of A is also called as rank of A. Dimension of the null space of A is also called as nullity of A, and here the dimension of row space of A is equal to dimension of column space of A. For all A it satisfies. And the theorem, if A is a m by n matrix of rank of A equal to R, then the dimension of solution space, the solution space is nothing but null space of Ax equal to 0 is n minus R, that is n equal to rank of A plus nullity of A. Rank of n is nothing but dimension of row space plus dimension of null space is called nullity of A. And here n is the number of columns of A. Number of columns of A given matrix A. Now we are going to solve this example. Find the row space, column space and null space of the matrix. Hence show that rank of A plus nullity of A equal to n. In this problem, we are going to find the row space, column space and null space. Let A be the given matrix. We have to reduce this matrix into row echelon form. That is, in the first column, we should make these two elements as 0 as the first step by using the row operations. So there is no change in the first row, second row and third row. So here we have to make this 1 and 2 as 0 by using the first row. In the first row, that element is 1, pivot element is 1, and we have 1 in the fourth row too. So we just subtract this fourth row minus first row. R4, the operation is R4 minus R1. We get 0, minus 2, then minus 4, minus 1, 0. Similarly, we have 2 in the fifth row and 1 in the first row. So multiply this first row with 2 and subtract with this fifth row. So the operation is R5 minus 2R1. You get the answers as 0, minus 1, minus 2, minus 2 and minus 3. As in the second step, we have to make the elements under this pivot element 1. This is a pivot element. Under this pivot element, all the elements should be 0. So there is no change in the first row again, second row, third row. And here we have minus 2 in this fourth row. Here the pivot element is 1. We have to use this pivot element. Here minus 2 is there. 1 is the pivot element. So multiply this R2 with 2 and just adding it. So the operation must be R4 plus 2R2. Then you'll get 0, 0, 0, 1, 2, and next operation is R5 plus R2. Just adding, you will get 0. Plus minus 1 and plus 1. Get 0, 0, 0, minus 1, minus. In the next step, this third column, all the elements are 0 already. So leave it. Here in the fourth column, this 1 is the pivot element. So under 1, we have to make these two elements as 0. So there is no change in the first and second row. Now the operation is R4 minus R3. Here the pivot element lies in the third row. So we have to use third row only. Just subtract this. We'll get 0, 0, 0, 0. All the elements are 0. The same way in the fifth row, R5 plus R3. We'll get all the elements as 0. This is the reduced row echelon form. Now in the row echelon form, the number of non-zero rows vectors forms the basis of the row space. So we can write the basis of row space as the number of non-zero rows. Here non-zero rows 1, 2, 3. We have only 3 non-zero rows. So these 3 rows vectors form the basis of row space. We can write basis of row space as 1, 1, 4, 1, 2. Second vector is 0, 1, 2, 1, 1. And the third vector is 0, 0, 0, 1, 2. So we can say the basis of row space is nothing but the non-zero row vectors in echelon form forms the basis of the row space. So here we have taken the given matrix as A and we reduced into row echelon form. After reducing it, we are taking the non-zero row vectors that forms the basis of the row space. What is the dimension of row space? The number of elements in the basis of row space is called its dimension. So dimension of row space is 3. We have 3 vectors in the basis of row space. So the dimension of row space is 3. Also we can call this as rank of A, rank of the matrix. Dimension of row space is also called as rank of A. Now we have to find the column space of A. Column space of A. Simply again we have to take the reduced row echelon form. I'm writing it again. A equal to 1, 1, 4, 1, 2. This is the given matrix A and reduced row echelon form. That is 1, 1, 4, 1, 2. Okay, this is the reduced row echelon form. Here we have to find the leading ones. Leading ones is nothing but the pivot elements. So here in this column we have This 1 is the pivot element. And in the second column, this is the pivot element. In third column, there is no pivot element. Fourth column, this is the pivot element. So these are called the leading ones. Leading ones. So in this reduced row echelon form, the leading ones lies in the column 1, column 2, and column 4, isn't it? Column 1, column 2, and column 4. Now we have to take the original column vectors. That is, original means the given matrix column vectors, same corresponding to C1, C2, C4. Column 1, C2, and C4 forms the column space. Again, I repeat, to find the column space of A, we have to reduce the given matrix into row echelon form, and in the row echelon form identify the leading ones. In this row echelon form, the leading ones lies in the column 1, column 2, and column 4. The corresponding columns in the original matrix, that is the given matrix C1, C2, C4, forms the column space, the C1, C2, and C4. So now we can write the basis of the column space. Basis of column space is 10012, 110 minus 1, 1, 11100. And the dimension of column space is nothing but the number of elements in the basis of column space, that is 3. Here dimension of column space is also called as nullity of A, that is 3. In the note, I have explained that the dimension of column space is equal to the dimension of row space. Here, look at the top of the screen. Dimension of row space equal to 3. Also, the dimension of column space is 3. In all the problems, dimension of row space is same as the dimension of column space. Now we are going to find the null space. So as I said earlier, look at the point number 3. The set of all solutions of the homogeneous system of equations Ax equal to 0 is a subspace of Rn called the null space of A. We have to find the solution of the system of equations Ax equal to 0. So the solution of the system of equations Ax equal to 0 is the null space of A. So A is the given matrix. And here we have 1, 2, 3, 4, 5 columns. So the solution matrix containing the 5 elements x1, x2, x3, x4, x5. So the number of columns is 3. We can write x1, x2, x3. So x1 to x5 we have written depends on the number of columns, because in matrix multiplication we multiply in this way, row into column, right? Equal to 0, 0, 0. We have 5 rows, so I have written 5 zeros. Now taking the augmented matrix to find the solution of the system of equations Ax equal to 0. The augmented matrix is nothing but the coefficient matrix together with this matrix. Now again, this matrix is also reduced to row echelon form. and directly I'm writing because we have already reduced it. Just I'm copying it. Again, writing this in the system of equation. Writing this as equation, we get x1 plus x2 plus 4x3 plus x4 2x5 equal to 0, x2 plus 2x3 plus x4 plus x5 equal to 0, x4 plus x5 equal to 0. We have three equations with five variables. Three equations with five variables. We know to find the five variables, we need at least five equations. Since we have three equations, we take two variables as free variables. So number of free variables is 2. So what are the free variables? In equation number 3, if you know x5, we can find x4. So let us take x5 as free variable. You can give any values. Let x5 as third equation implies x4 plus t equal to 0, x4 equal to minus t. We have got x4 value minus t and x5 as t. And look at the second equation. We know x5, x4, and we have two variables again x2 and x3. So we can take x3 as the free variable. So let x3 as s, taken as s. Now from the second equation, we can find x2 plus 2s, this x4 that is minus t, x5 is plus t equal to 0, and cancelling this we get x2 equal to minus 2s and x3 is also s. From the first equation, substituting all these values, x1 plus x2 that is minus 2s plus 4x3 4s plus x4 that is minus t plus 2x5 equal to 0. Simplifying, we get x1 equal to minus 2s minus t. Now we get the solution of the variable. So solution x1, x2, x3, x4, x5 is nothing but minus 2s minus t, and our x2 is minus 2x, x3s, x4 minus t, x5 t. Now writing the solution as sum of two matrices, minus 2, that is taking s plus t, sum of two matrices with two variables s and t, minus 2s minus 1t, again minus 2s plus 0t, 1s plus 0t, and 0s minus 1t, 0s and 1t. This system of linear equation have infinite number of solutions. You can take the basis of null space as basis of null space is this minus 2 1 0 0. The solution gives minus 1 0 0 minus 1 1. This is the basis of the null space, and dimension of null space equal to 2, and we also call it as nullity of A. Nullity of A. So now we found the dimension of null space. The dimension of null space is nothing but the solution of the system of linear equations Ax equal to 0. Now we have to prove dimension of row space plus dimension of null space equal to n. Here n is nothing but number of columns in the given matrix, columns of the matrix A. And we found the dimension of row space, that is the rank of A. We can write this statement as rank of A plus nullity of A equal to n. And rank of A is 3, nullity of A is 2, equal to 5. That 5 is nothing but the number of columns of A. So hence prove this theorem also. In this column we have found null space, row space and column space.